Hello students, here we will discuss about Malus law. Malus law means it is used in the polarization of light. First we will define its definition. Its definition is intensity of the light transmitted by the analyzer is directly proportional to square of cosine of the angle between transmission axis of the polarizer and the analyzer. It is the definition of Malus law. Now we will draw its diagram. Suppose that this is the main line and we have suppose that polarized like this. Suppose that this is the Polaroid, which is tourmaline crystal. This is the Polaroid. Now, when a light passes from the Polaroid, suppose that this is the unpolarized light. This is the unpolarized light which passes from the Polaroid. Suppose that here we insert Polaroid. It will polarize to the unpolarized light like this. Here is only the component in the plane of paper, but the component perpendicular to the plane of paper is diminished here. And here we insert a analyzer. This is the analyzer and it is making an angle theta with polarized portion of light. Now if we expand it, then it is making an angle theta, this angle theta. and here we analyze this ray with our eye. This is the P1, this is the P2, this is the analyzer. Now statements show that the intensity of the light are transmitted by the analyzer. This is the analyzer. The intensity of light transmitted towards this, the intensity, this is I, is directly proportional to the square of cosine theta, is directly proportional to the cos square theta of the angle between the transmission axis. This is the transmission axis of the polarizer and the analyzer. This is the transmission axis. This is the transmission axis. This is the transmission axis. Now the angle between these two transmission axes, suppose that we will draw here, suppose that the for P1, this is the transmission axis for P1 and this is the transmission axis for P2 and there is the angle theta in between them. Then I is directly proportional to the cos square theta. Now we will define it mathematically. Mathematically it can be written as if the electric field vector E naught between P1 P2, between P1 P2, here is the electric field vector E naught. This is, if E naught is the electric field vector, is the electric field vector between P1 and P2, between P1 and P2 is resolved into two rectangular components. Then E naught cos, here is E naught, the here will pass E naught cos theta. Therefore E naught cos theta passes through the analyzer, passes through the analyzer. Between P1 and P2 intensity is, say, I naught. This is the electric field vector, suppose that this is the intensity which is I naught between the P1 and P2. Intensity, let I naught is the intensity between P1 and P2. Therefore I naught is directly proportional to E naught square. This intensity, this is the electric field vector. This is the electric field vector. This is the intensity of light. This is the intensity. After passing through P2, let I be the intensity. After passing through P2, the intensity becomes I. After passing through P2, let I be the intensity. I be the intensity. Therefore, this derivation can be written as I directly proportional to, now this is equal to E cos theta, E naught cos theta, E naught cos theta square. Let this is equation 1, this is equation 2. Now dividing equation 2 by equation 1, dividing equation 2 by equation 1, and second equation is, this can be written as I upon I naught will be equal to E naught cos k theta divided by E naught square. This cut this, and from here I is equal to I naught cos square theta. This is the Malus law. This is the Malus law in polarization. Thanks for watching.